10-5 in Advanced Algebra 2, still dealing with our good buddy for right triangles. Who's our buddy? SOHCAHTOA. Still using it. Should be short and sweet today. Refreshing our memory. We'll have to draw our own pictures and stuff today, but angles of elevation and angles of depression type problems. Pretty easy. Elevation means which way to you, up or down. So something has to be, it's either a person or something, has to be looking up from a horizontal, right? You always base your angles of elevation or angles of depression from a horizontal. Cool? So here's our person right here. It says name all the angles of elevation. Well, what are the angles that are going up from any horizontal? What do you think? We got angles 1, 2, 3, 4, 5, 6. What do you think? Don't just put 5 and 6. They are what? So how do you want to write it? Angle 5 and angle 6. Okay? True or false? Measure of angle 2 equals the measure of angle 5. I'll let you guys discuss that. Your thoughts. What do you think? Measure of angle 2 equals measure of angle 5. Okay? If you want to say true, I need you to prove it to me. All right? I highlighted 2 lines in this picture, a red one and a blue one. Tell me what we will assume true about those. These are parallel lines. What kind of angles are 2 and 5? Oh, I like to hear that. They are alternate interior angles because aren't they on alternate sides of this green transversal right here? And they are between the 2 red and blue lines, right? So this is true. Now let's see if you can justify it. What was given to us? Parallel lines implies alternate interior angles congruent. You could say equal also if you wanted to, but it's really proper to say congruent. Makes me happy. Makes me realize when we went to 4th grade in geometry class, we remember. Name all the angles of depression. An angle of depression must go down from a horizontal. There doesn't have to be like a person in the picture, and they don't have to be looking down. It's based off any horizontal you got. Are there any angles going down from that horizontal? What do you think in this picture? 2, right? Because don't you go down from that red horizontal? Anything else? 3? What about 1 and 4? Let's definitely put 2 and 3. I'm down with that. What about 1 and 4? Does angle 1 go down from a horizontal? If you wanted to go down to get angle 1, you have to go down from this, which is oblique, correct? So angle 1 is not an angle of depression. What about 4? Same situation. And 5 and 6, we've already stated, were angles of elevation. Don't they go up from the blue horizontal? You go from the blue guy up, the blue guy up, right? So those are elevation. Yes? Well, if you want to go up, let me erase. Let me start over. 1 and 4, if you want to go up, you'd have to go that way. And is this a horizontal? That is a vertical. You with me on it? That's a vertical segment right here. Like to go elevation, if you sketch a little arrow, it's like, you know how we put arc marks in the angles back in the day? If you put an arc mark in there, right, that arrow has to go up. You see the green one goes down, but you're looking for like depression. That's not a horizontal line. This is not a horizontal line. All angles of elevation must go up or down, all angles of elevation must go up from a horizontal. All angles of depression must go down. So realize number 2, isn't this a horizontal? And if I want to put like an arc mark in angle 2, then I go down from the horizontal. Cool? Name 2 pairs of congruent angles. You and Pal can get that done. 2 pairs of congruent angles. Let's see if you can write it correctly before I have to show you how to write it. So someone said angle 3 and 6, right? Don't we have our parallel lines right here? And those are alternate interior angles. So angle 3 and is congruent to angle 6. Should you put little m's in front of those? When do you put the little m in front? When the measures are... Measures can't be congruent. Like if an angle measured 30 degrees and another angle measured 30 degrees, 30 can't be congruent to 30. They're just numbers, right? You know, it's like the measures are both 30, The angles are congruent and the measures are equal. If you use an M, you got to use an equal sign. We wanted congruent angles. Their measures cannot be congruent. The measures can't be same size, same shape, right? 30 degrees is not the same size, same shape as 30 degrees. There's no shape to it at all. They're just numbers. Cool. What else? There's one pair. Give me another pair. 2 and 5. We've already discussed that. Is there anything else that we could have chosen besides angle 2 and angle 5? 5 and 6. Why? Prove it to me. I will say if this triangle is isosceles, we'd have all kinds of cool things going. Do we know if that's an isosceles triangle or not? It looks like it. Would you agree it looks like it? Can we prove it? No. So if it was isosceles, you'd be in business. Can we prove angle 5 congruent to angle 6 or angle 2 congruent to angle 3 or anything like that? This is all we got. Cool? That's it. With more information, we can do more things. We don't have that information. Give the measure of the acute angle theta to the nearest degree. They give you an equation. They want to know the sine of theta equals 0.3. What would you do to solve for theta? Divide by the sine. So just divide by sin. That's what you want to do? What's 0.3 divided by sin? Like sin is just a function's name. Isn't there, when you type that button, the sine button, doesn't it have a cursor blinking here for you? Because you need to have the sign of something. So that doesn't work. You can't just get rid of 3 letters. What do we need to do? You do the inverse sign. Doesn't the inverse sign and the real sign multiply out to be -1? So inverse sine of 0.3 equals theta. Punch it in. And how do they want you to round it? To the nearest degree. So about what? 17 degrees. Tangent of theta equals the square root of 3 over 3. How do you solve for theta? You do the inverse sine. Excuse me, inverse tangent, my bad. Punch it in. I'll bet you get a really, 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 really neat number. Punch it in. Like super clean, awesomely round number. What'd you get? Well, wow. 30 degrees. You better type it in correctly. You got to put parentheses. It does it automatically. The tangent inverse of the square root of 3. You need to close that parenthesis, divided by 3, and close that parenthesis, and you will get 30 back. Numbers look familiar? So it's time to refresh our memory. 30, 60, 90 right triangle. Who is the key to a 30, 60, 90 right triangle? Short leg. Where's the short leg located? Across from the smallest angle, which is 30 degrees, right? 1. Then the hypotenuse is always twice as long as that. So if this is 1, that's going to be 2. And there is a radical for the third leg right there. Since it's a 30, 60, 90 that starts with a 3, this is going to be a radical 3. Tangent is what over what, according to SOHCAHTOA? And if we're doing this, isn't this opposite over adjacent right here? Would you get 1 over the square root of 3? That's not what that is, or is it? Doesn't it simplify to square root of 3 over 3? So there you go. These two. So stinking easy that it's hard. They're asking you to solve for theta. Is theta all by himself? Punch that in your calculator. Cosine inverse of 0.5. Does anybody know what 0.5 is as a fraction? It's 1/2. What'd you get when you punched it in? I bet you got a really, really nice number, 60 degrees. Because isn't the cosine of 60 going to be adjacent over hypotenuse? 1 over 2. And then the tangent inverse of 3. What'd you get for that? So about 72 degrees, right? Because they asked you to round to the nearest degree. Cool. We're going to draw our own pictures. Straight edge. Let me pass them out if you don't have them. The only hard part about these problems is drawing the picture. Once you have the picture drawn, I mean, it's just SOHCAHTOA. A ramp is to be built up to a doorway. Its slope is to be 1/13. And people don't know what that 1/13 is all about. I hope mathematically you understand what that word means. Have you seen that in a math class before? And if you was to have a slope of 1/13 on a graph, how would you graph it? You would do what? Rise over run, right? So rise over run, correct? Here's the ground. That's where you should really start your drawing at, the ground. And what they want this ramp to do is, here's the ramp in green. Doesn't a ramp go up, correct? For every 1 foot of rise, let me get my other straight edge here for a second. For like, when you rise 1 unit, whatever it is, do they tell us a label? They don't, you know. Should most likely be 1 foot right there. Like if they did 1 foot of rise, then they should have 13 feet of run. Cool? Which one's the run? The green one or the red one? Is that what you do on a graph? You'd do this, rise 1, run 13 obliquely. You'd run 13 obliquely. How do you run? Horizontally, correct? You know, so if this is your rise, then this is your run of 13. Cool? What are they asking? What angle does the ramp make with the horizontal? I'll give you a little multiple choice. Little a, little b, or little c. Which one are we looking for? The angle that the ramp makes with the horizontal. Little c. So here's what we need. We definitely need this in our picture. Ba-boom. And then let's put a theta in there. Because the angle we're looking for is this, so we'll call it theta. This is a right triangle. You want to use Pythagorean theorem? It's a right triangle. I got 2 sides. You want to use Pythagorean theorem? What would Pythagorean theorem get us? The length of the ramp, the hypotenuse. Do we want that? We want the angle that it makes. So since we're dealing with right triangles and we have angles involved, it's our buddy SOHCAHTOA. Which trig function are we using? Tell me what it's called. What's it called? Tangent of what? Equals 1/13, right? Opposite over adjacent. And then the tangent inverse of 1/13 equals theta. And then tangent inverse of 1/13. Oh yeah. What did they tell us? Around 2/10? About 4 point what? So theta is about 4.4 what? That should make sense. I hope you've seen a ramp before. I hope you realize that ramps are designed mostly for wheelchairs, you know, and there's no way that a wheelchair should climb a ramp that is that steep. You know what I mean? It should be very gradual, right? Very, very gradual. Small angle. Cool? Think about it. Next. The picture is drawn for you. But man, oh man, oh man, oh man, do we have a hard time with these pictures. Let's understand the picture because it's not drawn for you on your homework. A plane is flying at 31,000 feet. Isn't that the height of the plane? Right? So that's perpendicular from the ground. Its descent, please tell me what the word descent means to you. The plane's going to go down, but down from where? Down from this. Isn't this the plane's normal line of flight right there? He was flying horizontally. He must go down from that to land, at an angle of what they're calling theta in this case. Cool. Down from that angle of depression. If he needs to start going down right here, and the airport's right here, which they say is 125 miles away from where he was, cool, it says find the angle of depression. Well, this is not even in our right triangle, but based on what we did earlier, tell me why this is also theta. These are parallel to, boy, I'm having a hard time. These are parallel to each other, and those are alternate interior angles. So this, my friends, the red theta is not an angle of depression, though. Why is it not an angle of depression? It doesn't go down from a horizontal. You must realize that this is the angle that the plane starts to move down at. So go for it. Pause the video, give it a shot, better check back when you're done, video people. What we have discovered is that these are not in the same units. So I'm going to change this into feet by taking that 125 times 5,280. Getting a big old 66 with 4 zeros. Is that right? 1, 2, 3. Is that 4 zeros? Go back and put in a comma. And then I can do the tangent of theta to equal opposite over adjacent, 31,000 over 660,000. You don't have to reduce if you don't want to, but I'm going to say peace out to you. Zeros right there. No need to punch all those zeros in when I want to retype. The tangent inverse of 31 over 660 equals theta. And I hope I get a small number because that's how the plane's going down at. I don't want that plane to crash and kill me by going down so fast. I want it to go slowly of 31 over 660. Struggling. About what to the nearest tenth? That sounds like a smooth landing to me, right there. Groovy? One more. Talk me through it. What do you need to find first? Same problem we did last time with a different polygon. What do you need to find first? The measure of the sum of the total, right? Find me the total measure in this decagon. How many sides does it have? Boy, if you don't know, I bet you could count them. How many sides does a decagon have? 10. This will tell you the total degrees, number of sides minus 2 times 180. But then, aren't there 10 angles because this is a regular decagon, correct? So to find the measure of one angle, we just divide it by 10 again. So 8 times 180 over 10. What'd y'all get? 144 degrees is the measure of one of those angles. Awesome-o? It is also the measure of this angle right here. This picture is too tiny for me to want to deal with. Please sketch a new picture of triangle REG. And we just figured out that that measured 144 degrees. And each side is 10 inches. Is that what it said? What kind of triangle is that? Can we use SOHCAHTOA on him right now? Why can't we use SOHCAHTOA? It's not a right triangle. What kind of triangle is that? Isosceles, because it has, tell me the definition of an isosceles triangle. Not two equal sides, at least two equal sides. And when you drop this in, tell me what this is. The altitude of an isosceles triangle from the vertex, it does something special to this base right here. It perpendicularly bisects it. So if this is x, shouldn't that be x? Not only does that altitude perpendicularly bisect the base, it is also the symmetry line for that isosceles triangle. And if that vertex angle was 144 degrees, it bisects that as well to where this is 70 deuce degrees, and that is 70 deuce degrees. Cool? Can we use Sokotoa. Meow. Find x. We've got this nugget for a right triangle. This is opposite. This is the hypotenuse. So the sine of 70 deuce equals x over 10. 10 sines of 72 equals x. Instead of typing in 10 sines of 72, because all that's going to give you is this little x right here, what do you need to do to that when you're all said and done? Double it. So why don't you just type in 20 sines of 72 instead of 10 sines of 72? Sound cool? Because we need it times 2, so that'd be 20 sines of 72. But that's not what x equals anymore. 20 sines of 72. About 19 points. They say hundredths. So that's 19 point what? Do they give us a label? And it's about. Fabulous?